The optical heart rate sensor supports straight analog or digital signal output, which allows us to either read the pattern of the heartbeat or count real-time heart rate. Using the most basic Arduino IDE built-in examples. It comes with a wristband and a 3-pin jumper cable. To start, just attach the sensor to our body and hook up with an Arduino board. Before moving into setup, let's first take a look at the optical heart rate sensor and how it works. The optical heart rate sensor is based on PPG photoplethysmography technology, which may sound horrible to most of us. However, it is based on a very simple fact: blood absorbs green light. Each time our heart beats, it pumps a blood pulse into vessel. As a result, more green light is absorbed. Therefore, the intensity of reflected lights captured by the optical sensor gives us the density of the blood pulse. PPG technology is widely used in consumer wearable devices, such as fitness watches or smart wristbands. It is also used in professional medical devices for fast diagnosis. However, we would not recommend use these for diagnosis or medical treatment. But we can still get quite accurate reading with the optical heart rate sensor. Here are a few tips. Tip number 1. Stick the sensor onto area with higher transparency, so the sensor will be more sensitive to the pulse change. Tip number 2. Stick the probe on the skin with a stable pressure. Any change of their relative position may affect the intensity of the reflect light. Remember, a blood pulse can be generated by other factors, such as instant body movement or simply a press on the surrounding skin. Tip number 3. Make sure the body be still during the measurement. Or put the sensor in a place that is less likely to be affected by limb movements, such as chest, forehead. Apart from PPG, there is another measuring technology that is more trusted and accurate. It is called ECG, electrocardiography, which, namely, measures the electric pulse generated by cardiac movement. Here is another video explaining ECG heart sensor, and the sensor is available here. The following comparison gives us an idea of pros and cons. In general, PPG is good in terms of lightness and simplicity, while ECG is more accurate. Now it's time to get our heart rate monitor up and running. Connect to an Arduino board with an expansion shield or jumper wires. The optical heart rate sensor supports both analog and digital output. The analog output gives a pattern of heartbeat, while the digital mode only gives pulse count. Switching between two modes is extremely simple. To start with analog mode, turn the switch on the sensor to A side, which stands for analog. Connect the Arduino board to computer. Connect the signal pin to analog 0 and power up the sensor by 5-volt pin and GND pin. Open IDE, select the right board type and COM port. Then go to Example, Analog, and open Analog In-Out Signal. Upload the code to Arduino board. Once successfully uploaded, open the serial plotter. We will be able to see some random readings. Now, put the sensor onto finger or attach to skin. Hold still and wait for a few seconds. Heartbeat will be shown in the monitor. Meanwhile, the onboard LED also blinks at the pace of the heartbeat. We can also read the value from devices such as an oscilloscope, but we have to make sure the power supply doesn't exceed its 3.3 to 6 volt related voltage. Sometimes we only need the pulse count. Put it in digital mode. To start digital mode, keep the circuit unchanged and turn the AD switch to D. Of course, we may use any digital input pin to read the pulse. Heartbeats are now transformed into square waves, so every switch between high to low stands for a pulse change. To achieve this, a standard A to D converter is not enough, since the average voltage shifts throughout the time. Therefore, we need the A to D converter sense the voltage change instead of the voltage itself. The following circuit is used to to compare the voltage difference of the same analog signal, but between short intervals, which tells us whether the voltage is going high or low. If you are interested in going deeper, the schematic diagrams and other specifications can be found here via wiki page. Anyways, based on the square wave, we can calculate the heart rate by counting how many times the voltage shifts from low to high, or also high to low, in a certain time interval. To do this in Arduino, we have a library and sample code available from the wiki page. Import it into Arduino IDE. Heart pulse is calculated in every 10 seconds. Now the heart rate is being updated in real time upon a beat pulse is detected, and real-time heart rate will be displayed as a number in the serial monitor. Okay, that's all about this optical heart rate sensor. Remember, the sensor should never be used for medical diagnosis or treatment. If you think this video is helpful, please give us a thumbs up. Please also subscribe to our channel to learn about the latest open source hardware modules. If us have any thoughts or question, please also leave a comment below. Thanks for watching.